Welcome to a new test and teardown video. This time it is something completely different, I would say. This one is a PAG Films Limited London timer display indicator for, of course, old film. And we can... Okay, so this is just an indicator or something. The idea is that you can maybe see if the tape is running fast or slow or something like that. So I scored a lot of cool things from a film dubbing studio. They were throwing out everything, so I scored some really cool things, and this is a display for tape timing positions or something like that. And since this is probably 1960, 70, something like that, maybe even older, I don't know how old this one is. What kind of technology is this? Is it one of those really fancy, smancy ones? I don't have a big clue yet. So here at the rear, I bet this is mains entry, and look at that funny looking connector. I don't have a mating plug for this one. Encoder, input, output, reset, remote display. I also scored a remote display. It looks completely different, so maybe we're going to have a look at that one as well. Yeah, we better open and inspect. So, I don't know what exactly is going on here, but we got some really big circuit boards, but only 4 ICs, and I see some counters. Okay, all those wires. Wow, what the transformer is mounted on some really big standoffs. Why? And it says here PAG Films type 420, and this is side 2, la 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 la. But look at the displays. I already think I know what is going on here, but I think this is bulbs. Or neon bulbs, maybe even. We better remove the front glass and see if there's any way to see what is going on. So with the red front acrylic removed, I think we can see a little bit more of those displays. Yeah, it looks like there is some thin plastic here. So what is the idea exactly? How do we open these? Maybe I'm a little bit afraid of what is this screw doing. But maybe it's those tiny little screws. Yeah, see, this one is a little bit... So the idea is definitely not the tiny screws, it's the big ones. And then you take out the entire unit here in one go. So I need to put in the tiny little screws again. But I just wanted to show what happened here. So the big screw goes in here, and it goes through this thread and holds everything together in one piece. But since I accidentally removed the tiny little screws, we should be able to remove everything like that. And then we can see how this is made. Thin sheet of white plastic, and then I think this is aluminium or something like that. It's really solid. Look how beautiful that is made with the reflectors like that. And I think the idea is they want to light up the entire area, same brightness and something like that, right? Isn't that just one amazing 7 segment. What a score. So this will be the 7 segment driver board. And we got a lot of good news here because the 4 big chips, they're all 7448. So that means 4 bits in, and then they 7 segment decode with some lamp test and some latch. No, not latch, but some enable or something like that, right? So now the 7 segment signals, they go to those little 8-pin ICs, and they're called 75452B, and they are still around. You can still buy those. They are like a half an amp open collector transistor drivers, and we got 2 of them in each IC. So that will be the 4 connectors to the 7 segments. And of course we got 1, 2, 3, 4, 5, 6, 7. And then we're done. And then again, la 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 la. So that is how it's made. So I think I will be able to access this interface here and then be able to handle the display. But when I look at the connections here, it looks also a little bit weird. I should have at least 4 bits per IC, some power and some other things, and that is probably what I got. Some okay, so that is, yeah, I got that, and probably a little bit more as well. So this big cable here goes to those 2 connectors right here, and I pulled out the 2 circuit boards, and the bottom one is the one with all the counters. See, 74190, and we got 6 of those. We got a little, no, there's another one. We got some NAND gates, we got some other gates, and a little relay, some more gates. Yeah, actually quite a lot of NAND gates going on here on that board. It's of course from 1976 or something like that. Most of those chips are from 1974, 76 or something like that. It's a 2-layer board. Let's look a little bit more on the top board here. Is just some gates. So I don't think that is super important. It could be interesting to try and power this up, but I'm a little bit worried how much voltage should I give this thing. I see something here on this capacitor. It says, see, 250 volts, 50 hertz. So that is a mains filter. So this tells me it is regular mains voltage I need to go in. I can't really see, only 20 VA. Maybe there is something written with voltages. 240. See? So if this one is 240, then it's perfectly fine. Oh yeah, there was one other little sexy detail here, and that is this mains switch. And look at the quality level here. We got micro switches at the back, and then some mechanical construction that pushes those. It looks like they're not pushing it all the way. Maybe I need to give this a little bit of lubrication. Oh, that is nice. So let's try the first power up. Let's dim the light a little bit here like that. And first, We power on here and there's not a lot going on, and let's try this one. Okay, it only, no, it seems to be, it's using 12 watts. Oh, there's even a little bit light in the main switch, but of course we don't see anything here on the display because no input, no reset, no counting is going on. So I now need to go and figure out how to get some pulses in or some signals in. I'll check that we got some voltage going on and such. No, I don't see any. Could have been cool with a little lamp test the first 2 seconds, I mean, but that's probably just how I feel about it. So I took out the power supply from this corner because I got 0 volts on my BCD to 7 segment decoders. There's super easy to find pin 8 and pin 16. 0 volts on all these, so nothing is working here. And this power supply here, that is the one we had up here. So I just measured across this capacitor here. That is the output voltage, again 0 volts. And then I took my meter in AC mode and I got 5 volt AC here. So I bet this is the entry to the rectifier. It looks like the solderings here, they're good and fine. And then we get like 9 volts. And then it's regulated to 5 volt. I think that is how this one should work. So now I want to remove those 2 wires here and play with a little DC supply and see if I can recreate whatever here is not working. So I just removed one of the wires on the transformer, and this is difficult. So this is 6 volts input, oh, and 4 volts output. If I give it a little bit more, this is not looking too good. If I give it a little bit more, 8 volts. So what exactly is going on here? Maybe it's some AC? No? So probably you need some more volts to start this thing up. So 10 volts input. Okay, so that regulator here is not too good. Maybe it's the ground connection or something. Maybe I just resolder it and see if it works. So let's try and see what happened. I did a little re-screw and a little bit of resoldering here, and oh, I forgot to put in there. We've got 10 volts input. Oh, and now we got 4 point. See? That is 5 volts. So it was just a bad connection here. Haha, I will try and put this back together. So let's try again and see if there's any voltage. This time I monitor the voltage on this supply, and I got 5 volts, and now it's using 25 watts. So that is a lot better. And now I want to try and investigate the signals in and out. And I should definitely also try and measure the voltages down there. But now this is a good start. Imagine this thing uses 25 watts in idle, what is it going to use when those lamps they light up? So now I got one digit that is lit. I'm sorry this is not super visual on the camera because it's auto-correcting the balances and all that, but in real life this looks super nice. And I can't really explain why I only see one, because with nothing connected, all the inputs, I mean, this should of course show the same. And this is a non-valid input, obviously, but why? So maybe all the bulbs are defect or something like that. So we got 10 volts on the common rail here to all the bulbs, and then we're using 3.5 of those driver ICs per segment, and there you have the BCD SU7 segment drivers with 4 bits input, and those 4 bits they go via this cable all the way up here. This is actually this one. So those 4 bits from the last one goes up here, and I added a little arrow here. So the output from this buffer driver board goes with those 4 arrows down to that last driver chip. This input here is this first one. I didn't bother to explain more in this first little go. So let's look. The driver board, we got 47408. That will be quad AND gates. And here again I added the little arrows, the 4 output and only 1 input, so you get the idea. So let's mark all the 4 outputs from this board to my display. So those 4 outputs, they go to this AND gate. See, 1 output. It's a little bit funny. They take 2 of the inputs to the AND gate and connect them in parallel. So you need to drive 2 inputs. That is a little bit stupid. They should of course have taken all the other inputs and held them high, and this way you have a driver or a buffer amplifier. Why would you put 2 inputs in parallel? I don't understand that. Anyway, the inputs to this board, again 4 inputs, they are connected down to here. So this is the last one of them. Doesn't really matter so much. So here is the counter board, and I have mounted or marked that signal. It goes to this counter chip right here. So of course there will be the 4 bits that goes out of this counter. So this one is a 74190. So this is a little bit special chip. So it's a loadable and then countable. So we've got 4 bits input, some latches, and then 4 bits output. And you can load and you can count. You can even count up or down. And of course they're using this chip because the tape can go forward and backwards. And it can go fast and it can go slow and all sorts of stuff. And you can also, probably you will have a remote control where you can preset the time where you know it is and then start the tape from there on whatever you want to do. So I think this is all the interesting parts. I want to input some clock to this chip and then see one of the digits running, and then I want to figure out where is this clock going. But first I definitely have a problem with this. This is not that, it's not doing what I expect. I think this unit is absolutely fantastic. The way that it counts, because of the bulbs, the way they glow up and down is just fantastic. Let me try and show what I've done. This is a clock signal that I was able to loop into one of the counters. And now we can see it's counting. I don't know how visible this is on the video, but you can see it's nice and smooth. Really, really a nice look. We got some problem with the counters to load them, set them, preset them, and all this kind of stuff. There is a lot of stuff. I just made them wrap around, and now it seems to be more or less solved. There is a lot of extra counters that is doing a lot of extra things, because this is 80 kilohertz of clock. And if let's get down to 8 kilohertz, I think there's definitely some funky stuff going on here with the clock and the way this, probably some digits missing or something. But at least it seems to be overflowing more or less correctly. There's still a lot of investigations going on with the counter board and figuring out what is doing what. So here is how I handled all this stuff. The load signal, we need to have this correct, otherwise it's not counting at all. It's just going to stay in load condition. So that load signal goes to all those counters, and there's quite a lot of them. But we only need 4 of these to handle our display. So I bet all those additional, see, we got 7 of them, right? And then this load signal is handled using this NAND gate and this relay. So I was able to activate the relay, and now it's not in constant load. And then the clock, this goes via this. It's a dual little flip-flop timer IC. This is 74123, and the top one here is the clock signal. This is a little signal for my scope, and then I figured this is the input, and this input goes via a lot of other chips that is handling the clock. Goes actually all this stuff, and I haven't really figured out exactly what is going on here. I gave up following the different signals around here, so I'm just overdriving this output with my signal generator. My signal generator can just win over the output from this one. So this is not the best way to do it, but at least I got the damn thing counting. So after a few more days figuring out what is what here, my idea is I want to be able to preset everything to 0, so I can have a clear and a count. And that's actually all I want. This way I can set this for a number. Just start with 0 and then count up really, really fast so you can't really see it. And there you have it. Then it's just counting maybe I can use this for a clock. That is what I think. It's just using very, very few wires. And then one of these ESP32s with internet time programmed into it. And then I'll get a pretty cool clock. The only thing it's using, I think it was 48 watts with all the lamps on here. It's way too much. But it's quite easy to pull out the bulbs and put in LEDs. But then it's just an LED clock once again, and that is probably not what I want. But it's the way that the bulbs glows here is just so nice, just to leave this as it is. If you got any cool comments about what should I use this for, how to implement something cool, fascinating, whatever you would have done with this one, please tell me. And maybe I'll do a follow-up, or maybe I will do exactly what you told me to do. We will see what happens. Thank you very much for watching so far. Bye bye.